If you fell into Jupiter's atmosphere, you wouldn't hit solid ground. You'd fall for hours through progressively more extreme layers where pressure climbs to millions of times Earth's atmosphere, temperature exceeds the surface of the sun, and hydrogen compresses into metallic states, crushing and vaporizing you long before reaching whatever core might exist thousands of kilometers deeper in infinite atmospheric descent. Jupiter is the largest planet in the solar system, but there's nothing to land on. It's a gas giant, layers of hydrogen and helium compressed by gravity into states Earth never experiences. You enter at 50 kilometers per second, the speed of anything in orbit around Jupiter. Friction hits you like a wall of fire. Entry phase begins at 50,000 meters per second, 10 times faster than a rifle bullet. Air resistance strikes instantly. Your body temperature spikes to thousands of degrees in seconds from friction alone. This is re-entry heating, identical to what spacecraft experience when returning to Earth, except Jupiter's atmosphere is far thicker. You vaporize before you comprehend what's happening. Even inside an indestructible heat-shielded capsule, deceleration would crush you. 20 to 30 times Earth's gravity pressing down on your chest, your organs rupture, your skeleton shatters under forces your body was never designed to withstand. Most spacecraft would disintegrate from structural failure alone. You're dead within the first minute, killed by heat and deceleration combined, long before you reach the depths where conditions become truly extreme. Assume somehow you survive entry in an engineered capsule designed beyond current technology. You fall through the first visible cloud layer, ammonia ice crystals floating at minus 150 degrees Celsius. Pressure here roughly matches Earth's sea level. Temperature is Antarctic winter. This is the most survivable layer of Jupiter, and it's still a toxic freezing hurricane with lightning. Wind speeds exceed 400 kilometers per hour, stronger than any tornado on Earth. Lightning bolts arc between clouds with 1,000 times more power than Earth strikes. You're being tossed through poison fog by hurricane winds in total darkness with megawatt electrical discharges. Already, this environment is worse than anywhere on Earth, but you keep falling. Deeper into the atmosphere, pressure increases to 10 times Earth normal, equivalent to diving 100 meters underwater. Temperature climbs to 0 degrees Celsius, the freezing point of water. You're now inside layers of ammonium hydrosulfide clouds and water vapor. The pressure is still technically survivable for a suited human, but temperature is rising fast. Wind speeds intensify. Visibility drops to 0. No sunlight penetrates this deep. You're in absolute darkness except for occasional lightning flashes. The distinction between up and down becomes meaningless. You're falling through a black void that's getting hotter and denser with every passing minute. 50 kilometers deeper, pressure reaches 100 times Earth's atmosphere, submarine crushing depth. Temperature hits several hundred degrees Celsius, hot enough to boil water instantly. Your capsule is withstanding forces equivalent to deep ocean trenches while being baked like an oven simultaneously. Hydrogen gas becomes so dense it starts behaving more like liquid than gas. The line between gas and liquid blurs into something called a supercritical fluid, neither fully one nor the other. No spacecraft humans have built can survive these conditions. The pressure would crumple titanium like aluminum foil. Temperature would melt electronics and vaporize seals. You're being crushed and cooked at the same time. You're 50 kilometers into Jupiter's atmosphere. Pressure is 100 times normal, like being 100 meters underwater. Temperature is several hundred degrees. Your theoretical capsule might survive another 50 kilometers before catastrophic failure. Do you continue descent, collecting data until destruction, or attempt to turn back and ascend while systems still function? Calculate your options. Remember, escaping Jupiter's gravity well requires enormous thrust. Ascending costs more energy than descending. Physics makes this a one-way trip the moment you enter. There's no turning back. You chose descent. Descent is what you get until the end. Hundreds of kilometers deeper still. Pressure exceeds 1 million times Earth's atmosphere. Temperature reaches 10,000 degrees Celsius, hotter than the surface of the sun. Hydrogen is compressed so violently that electrons separate from atoms and it transforms into metallic hydrogen, a state that doesn't exist naturally anywhere on Earth. This material conducts electricity like copper, but flows like water. It's neither gas, nor liquid, nor solid in any way you understand matter. Jupiter's magnetic field traps charged particles here, creating radiation levels that would sterilize anything organic in seconds. At this depth, the concept of you stops making sense. Pressure and temperature exceed what atomic bonds in your body's molecules can withstand. Your capsule, your equipment, your body, everything disassembles into component atoms. There's no consciousness left to experience it. You don't die, you simply cease to exist as organized matter. Scientists theorize Jupiter has a core somewhere deeper still, possibly rocky, possibly metallic, possibly dissolved into the surrounding metallic hydrogen ocean. Nobody knows for certain because we can't see it or reach it. If it exists, pressure there is estimated at 45 million times Earth's atmosphere, temperature estimated at 35,000 degrees Celsius. These are speculative numbers based on models. What's certain, you never reach it. You're destroyed thousands of kilometers above, crushed and vaporized in layers of compressed hydrogen that behave like nothing Earth has prepared you to understand. Which is worse, falling into Jupiter where you're crushed and vaporized over hours of descent through progressively more extreme layers, or falling into a black hole where tidal forces tear you apart in seconds? Both are infinite falls with no landing. Both are inescapable destruction. Jupiter gives you time to understand what's happening as each layer progressively erases you. A black hole kills you so fast your nervous system can't process it. Think about it. Which terrifies you more? Slow compression into atomic dissolution or instant tidal shredding? Both scenarios remove any concept of you from existence. Comment your choice. Jupiter has no surface because there's no sharp transition from atmosphere to ground. Pressure and density increase gradually. Gas becomes denser. Dense gas becomes liquid. Liquid hydrogen becomes metallic. Metallic hydrogen possibly becomes solid at the core. But solid at those pressures and temperatures doesn't mean you can stand on it. It means matter is compressed beyond anything your experience can reference. You don't land on Jupiter. You fall until conditions destroy the chemical bonds that define your body's structure. There's no bottom, only increasing hell. NASA's Galileo probe descended into Jupiter in 1995, the only human-made object to attempt this journey. Cutting-edge engineering, titanium pressure vessel, ablative heat shield. It lasted 58 minutes, reached depth of 160 kilometers before pressure and heat crushed it into silence. That's barely scratching the surface. Jupiter's atmosphere extends thousands of kilometers deep. The probe transmitted data until pressure exceeded 24 times Earth normal and temperature hit 150 degrees Celsius. Then it died. That's what the most advanced engineering humanity could build at the time. A human body would last seconds during entry from friction heating, maybe minutes in the upper clouds if somehow protected. You'd never reach the depths where hydrogen becomes metal and temperature exceeds the sun. Physics kills you long before you get that far. You're designing a Jupiter descent probe with current technology. You can prioritize one protection system: heat shielding to survive entry temperatures, structural reinforcement to survive deceleration forces, or pressure resistance for deep descent. You cannot have all three with present-day materials and weight constraints. Which do you choose? And how far do you think your probe would reach before it fails? Think it through. Entry heat kills you in seconds if unprotected. Deceleration crushes your instruments if not reinforced. Pressure destroys everything deeper than 200 kilometers if not built like a submarine. Pick one. The other two kill you. That's the engineering reality. The largest planet in the solar system has no place to land. You could fall for hours, never hitting ground, just sinking deeper into increasing pressure and heat until you cease to exist as organized matter. Jupiter is a planet-sized atmosphere with no bottom, only infinite crushing descent. The journey doesn't end with impact, it ends with gradual disintegration as pressure and temperature exceed what your body's atomic structure can withstand. You don't die on Jupiter, you dissolve into it, layer by layer, until there's nothing left that was once you. Physics is patient. Jupiter has infinite time. You have minutes at most. We call it a planet, but there's nothing planetary about it in the way Earth is a planet. No ground to walk on, no surface to map, just atmosphere compressing into stranger and stranger states the deeper you go. until eventually maybe there's something solid at the center. But that's speculation. What's proven, everything we've sent into Jupiter has been destroyed within an hour. Everything we ever will send will meet the same fate. Because Jupiter isn't a place you visit, it's a gravity well lined with progressively more lethal physics. And once you enter, the only direction is down, into conditions that erase the distinction between being alive and being matter. Entry velocity, 50 kilometers per second. Survival time, measured in minutes. Depth reached before destruction, a fraction of 1% of Jupiter's radius. That's not exploration, that's controlled disintegration. And there's no bottom to hit, just falling forever into hell that gets worse with every kilometer until physics disassembles you atom by atom.